Set yourselves up for an incalculable catastrophe of outstanding extent. Balu, the red Goliath star, adjusted on the edge of our framework, is passing on terrible messages through the universe. Using the James Webb Space Telescope, cosmologists have revealed something essentially fomenting about this gigantic brilliant body. As famous astrophysicist Brian Cox gives a grave admission, the question looms, would we say we are on the grade of seeing a shocking infinite blast impact that could everlastingly change the night sky? To the extent that we may be concerned, we ought to make a dive into the astonishing, weaved craftsmanship of the universe where stars are imagined, live, and pass on in amazing plan. One star has actually gotten the imaginative brain and stress of cosmologists and the public alike. This star is Balu, a red, very Goliath of monstrous extent and age, situated noticeably in the grand body Orion. Its obvious bronzed color and variable magnificence had for quite a while been a wellspring of interest. However, progressing upgrades have reinforced interest in this sublime beast. As we research the possibility of Balu, we end up on the cusp of a perhaps incredible event in the presence example of this star. Regardless, what could these movements in Balu anytime suggest? Might it, at some point, be said that we are seeing the prelude to an endless showcase of unimaginable scale? Balu, generally many times greater than our Sun, is a heaven behemoth. Its tremendous size is almost outside human capacity to get a handle on. Imagine a star so colossal that were it to displace our Sun, its surface would extend beyond the orbit of Mars, overpowering Mercury, Venus, Earth, and Mars in its brilliant embrace. This is not only a show of Balu's true characteristics, but also represents its stage in the eminent life cycle as a red super-red very Goliath monster. Balu is in the dusk of its presence, a phase described by development and cooling following a life spent merging hydrogen into helium in its middle. However, what about the hour of Balu? This star, believed to be around 8.8 to 8.5 million years old, is mostly young in human terms yet ancient with respect to magnificent lifetimes. It's as the two continuous red very Goliath stage, perfection of millions of extended lengths of glorious improvement, a period set apart by close to personal changes and cycles that have transformed it from a hot blue star to the red Goliath we see today. The presence example of stars, as is Balu, is a record of progress driven by the consistent powers of nuclear fusion and gravity. B's indisputable ruddy shade is another indication of its continuous stage. The red tone is an outcome of its rather cooler surface temperature diverged from different stars like our Sun. While the Sun's surface temperature is around 5,500 Kelvin, B's cooler surface registers temperatures around 3,500 Kelvin. This cooler temperature allows Balu to transmit light at frequencies that give it a red appearance. However, this tone isn't just a visual quality. It gives snippets of data about the star's condition and the cycles it occurring inside massive gaseous spread. Adding to B's persona is its genuine variety. Change Old Roman and Chinese works recommend that near a really long time back, Balu was yellow. It was solely in the 900 years that Arabic specialists initially depicted it as red. This variety shift over humanity's set of experiences isn't essentially a detail there of psyche of cosmology but a clue to the star's extraordinary way. The variable quality of Balu is another fascinating perspective. It's a semi-standard variable star, and that implies its light sometimes travels every which way. Moreover, this variability is a brand-name dance of glow that has intrigued stargazers and skywatchers for a truly long time. Regularly, Balu goes through a Betelgeuse decreasing multi-day cycle alongside a more extended cycle that stretches something like 5 years. These cycles have been recorded as far back as 1836 by Sir John Herschel and possibly considerably earlier in local oral traditions. However, what makes Balu truly obscure isn't just its changing quality but its inconsistency. Not at all like many stars that follow an expected model, Balu irregularly diverges from its melodic reducing and illuminating, demonstrating multifaceted and less understood processes occurring inside its amazing design. Continuous, earth-breaking discoveries certainly stand out of cosmologists and stargazers in general. With a frightening and hair-raising change in its appearance, an event now widely known as the unique lessening in late 2019, the red supergiant Balu, perhaps the most awesome star in the evening sky and a perceptible part of the Orion grand body, began to lessen bafflingly. The star's reducing was verbalized to the point that it began losing its glow at a run-of-the-mill pace of 0.01 sizes every day, showing up at its most diminished wonder in February 2020. Balu, customarily clear to the unaided eye, even in light dirt districts, ended up to be extraordinarily fainter, a change noticeable even to amateur observers. However, there's one issue with endeavoring to screen the activities of Balu: the time oddity. Exactly when we look at a star like Balu, we are not seeing it as it exists in the present but as it was before. As a result of the time it takes for light to make an excursion to us, in Betelgeuse's case at around 725 light-years away, the light we see today left the star nearly 7, even hundreds of years earlier. This defer makes it attempting to predict and screen unforeseen changes in a star's method of acting, as we are fundamentally looking into its past. The B obscuring event filled in as an indication of the characteristic inconveniences and the hindrances of our cognizance while dealing with the colossal, gigantic extensions and the time oddity they present. The spreading out of B's divine show was firmly checked by Andrea Dupree, accomplice administrator of the Center for Space Astronomy at Harvard and Smithsonian, and her gathering. They utilized Hubble to separate the behemoth star as a part of a 3-year study to separate assortments. B's outer climate. These insights offered unique information into the components of a variable star like Balu, which reliably expands and contracts, causing changes in wonder. Hubble's antipathy for splendid light allowed the experts to test the layers over the star's surface, which were warmed mostly by the star's furious convection cells. Further assessment of the Hubble spectra taken at different concentrates generally through 2019 and 2028 in assessing the advancement of material in B's outside environment. Specifically, the spectra focused in on magnesium-2 lines which are normal for the star's ecological conditions. These insights showed material moving at paces of around 200,000 miles per hour from the star's surface into its outer air. This hot, thick material eventually extended extraordinary miles from Balu and was the trailblazer to the buildup cloud that prompted the star's obscuring. Dupree and her gathering evaluated that twice the conventional proportion of material from B's southern portion of the globe was lost over the 3 months of the AR corruption. This mass adversity was enormous, especially considering that Ju, like all stars, interminably lose mass, however, at a rate undeniably more critical than that of our Sun. The size of this mass send-off and the subsequent obscuring began discussions among cosmologists about whether this event could be a precursor to an infinite blast chute. The proximity of Balu, around 725 light, a very long time from Earth, adds to the interest, as any such impact would be observable from Earth and give an exceptional opportunity to see an infinite blast extremely close. However, this has yet to be tended to. What does this obscuring event anticipate for B's future? Is it an indication of an approaching vast blast or simply an uncommon episode in the star's long and complex life? A couple of theories were proposed to figure out this startling change. One transcendent theory proposed a phase in the grandiose blast impact process, a theory that got some respectable forward development in view of the ordinary conviction that Balu is drawing closer a marvelous completion. Another notable theory is trapped dust, possibly from the real star, obfuscating our view. Balu, as other red supermonsters, is known to shed material, and it was felt that this material could shape a buildup cloud adequately thick to decrease the star's light as per our place of view. A third explanation considered changes in the star's photosphere, the perceptible surface layer, which could impact its obvious splendor inside and out. Assessment using unique observational methods loosened up this mystery. Spectroscopic assessments showed a drop in B's convincing temperature, suggesting that the decreasing would be able to be a direct result of a gigantic faint spot on the star's surface. This theory was maintained by the insight that B's temperature diminished by something like 170 Kelvin around the hour of the lessening, highlighting enormous changes on its surface. In the end, the approach to understanding this unusual idiosyncrasy came from humankind's sentinel in space, the Hubble Space Telescope. Hubble's discernments revealed that the lessening of Balu was most likely brought about by an immense send-off of hot material into space. This material formed a buildup cloud that obscured a piece of the star's surface, truly reducing how much light reaching us from Balu. The buildup cloud was acknowledged to have framed from very hot plasma, which shot out from a gigantic convection cell on the star's surface, and a while later voyaged through its hot climate to the colder outer layers. As it cooled, it formed dust grains, making a cloud that blocked light from about a fourth of the star's surface. Hubble's splendid light spectroscopic insights, what began in January 2019, were fundamental in figuring out the course of occasions clearing the way to Balu darkening. These discernments got signs of thick, warmed material going through the star's climate in the months going before the reducing in December 2019. A couple of ground-based telescopes in like manner seen the star reducing in quality, particularly in its southern side of the equator. This material, which was from the get-go more brilliant than the star's regular splendor, over the long haul prompted the improvement of a foreboding shadow as it moved outward and cooled. The hypothesis was that this outflowing material and the subsequent foreboding shadow caused the star's sudden lessening. The size of this send-off is truly astonishing, moving Balu into an enormous spotlight. The star's remove moved and anticipated 400 billion times the mass commonly conveyed in a standard piece. This removed material, acknowledged to measure a couple of creases how much as our moon, was an enormous event for Balu as well as for how we could decipher eminent mechanics. However, how should such a huge release of material impact Balu and astronomical blast hypotheses at large? The consequences for infinite blast theories are critical. Standard cognizance sets that read supermonsters like baled mass at a rather reliable speed before the dangerous completion of their lives. Not enduring the size of this send-off challenges this thought, proposing a more stormy and maybe inconsistent completion of life stage for these stars. Could you eventually get ready for its incredible finale? An enormous blast chute? Inside the accompanying several hundreds of years, late assessments guess about the preparation of such an event, suggesting that it might be sooner than as of late thought, potentially in just a numerous years. Bow shock is another essential piece of the bow puzzle. As this tremendous star tears through space at about 67,000 miles per hour relative with its enveloping interstellar medium, it makes a bow shock comparable to the wake formed by the bow of a moving boat. This characteristic occurs as the star's outside layers interact with the interstellar gases and buildup, giving a breathtaking showing of the star's dynamic nature and its correspondence with the huge environment. The examination of this bow shock enlightens us about B's current status as well as adds to how we could decipher sublime headway and mass setback processes. However, what of the star's new approach to acting? Balu's surface has been seen to cool and end up being less thick following the release event, leaving the star in an unstable state. Even a long time later, hydrodynamic reenactments suggest an affiliation between the star's convective activities, the mass release, and coming about pulsate mode trading. This non-stop insecurity raises issues about the internal cycles driving these movements and how they could complete from here on out. Besides, the mass hardship speed of Balu, as seen, is basically higher than various stars, indicating a bewildering exchange of internal powers. The determined pulse, somewhat liable for this mass mishap, is limited by the consistent energy dispersal through shock force and mass release. Such insights include the dynamic and genuinely impulsive nature of B's life cycle, moving cosmologists to reevaluate their models of eminent improvement. With this large number of profound changes, is Balu close to the actual edge of going vast blast? The question presents a possible danger in the cosmic nearby region. While the preparation of such an event remains problematic, the new, marvelous mass release has without a doubt moved the conversation, showing a more new-to-the-scene end than as of late expected. Theories right now wrestle with the repercussions of such monstrous material mishap and how it influences the star's stability and future. However, as the cosmic neighborhood anxiously looks at Balu, another tremendous event gets our thought and offers an unmistakable close concentrate on the vast blast SN 2023 ISF. This phenomenal impact occurred in the world's more tumultuous one, conversationally known as the Pinwheel System, situated a critical 21 million light-years away. Discovered in May 2023, SN 2023 ISF fills in as a reminder of the dynamic and reliably changing nature of the universe where stars continue without their lives in a fabulous group of creation and destruction. As we continue to unravel the privileges of the universe, Balu remains as an aid of exposure, offering encounters into the inside activities of stars and the powers that shape our divine scene.